All right, so today we're going to look at practice C, which is current, and practice D, that is resistance. I'm going to do C2 first because C2 is a little bit, it has one more step than C1. All right, so again, we're always going to write our given and our find, because by writing our given and find, it helps us to figure out what equation we want to use. It says, in a particular television tube, a beam of current is 60 microamps. So current is I, and if I wasn't sure about something, I know that amp is the unit of current. Now what we said was, before I go on, because I wrote a prefix here, I don't want to make a mistake and not convert. So right now in my given, I'm going to say, well, micro is a prefix that means 10 to the negative 6. So I'm going to rewrite this and write I is equal to 60 times 10 to the negative 6 amps. So I won't forget to do that. It says, how long does it take? So when it says, how long does it take, I know I want to find time. For 2 coulombs of charge, and I'm reading the wrong column. How long does it take for 3.75 times 10 to the 14 electrons? So they're telling me the number of electrons is equal to 3.75 times 10 to the 14. That's the number of electrons. So right away, I wrote that in my given, but I didn't do any problem like that. So I'm not really sure what that is. So I'm just going to write it down. These are your problem-solving strategies. You don't just give up and say, I don't know how to do that because I can't just plug it in the equation. I'm going to think about it. So you write down what you read. So then it says, so I want to find how long it takes. Okay, so they tell me the number of electrons. So you see in parentheses, it says hint. Recall that an electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. So the charge, little q of an electron, is 1.6 times 10 to the negative 19 coulombs. So what I want to do here, I want to find T. Now I know that I is equal to delta Q over delta T. So this is the total charge over the time, and this is the current. So I'm going to rearrange this equation because I want to solve for T. And I'm going to say that T is equal to delta Q over I. So this is the total charge over the current. So now when I look at my given, I have the current. Now as far as the total charge, I just have the number of electrons, and then I have the charge on each electron. So now I can say that this, now watch this, as far as delta Q, I have 3.75 times 10 to the 14 electrons, right? And then the charge of one electron is going to be negative 1.6 times 10 to the negative 19 coulomb per electron. So you see here I have electrons in the numerator and electrons in the denominator. So you see how now this gives me the total charge in coulombs that I have? Okay? So even though they didn't tell you the total charge, because they told you the number of electrons and then they told you the charge of an electron, you can find that. And then the total current would be 60 times 10 to the negative 6 amps. So now on my calculator, I'm going to press 3.75 EE14 times, and I'm not going to worry about the negative now, 1.6 EE negative 19 equals divided by 60 EE negative 6 equals. So it comes out to be exactly 1. So T is equal to 1 second. A coulomb per amp is a second. So that's it. So the point of this is when you're reading a question, you just don't give up and say, why did they give me the number of electrons? So again, if I have 3.75 times 10 to the 14 electrons, and then I know the charge on an electron is 1.6 times 10 to the negative 19 coulombs per electron. That's why we learned in the beginning of the year, when you write something, you write it like this. So then I see this electron and this electron cancels, and then I get my total charge. Okay, so that's why I did number 2, because number 2 was a little bit different with that step. All of the problems in practice C are using this equation. Because remember, in your book, they introduce an equation, and then you practice using that equation. Okay? So that's the only thing that made it a little bit more challenging. All right, now we're going to look at practice D, which is resistance. Now, these are all equally easy, so I'll do D1. So D1, remember, we're going to write our given. We're going to write our find. And these are all going to use the same equation. They all use Ohm's law. So it says a 1.5 volt battery. So I'm given that V is equal to 1.5 volts. Remember, we're going to chunk this. As we read something, we're not going to read the whole question at once. Each time we read something, we're going to write it down. Is connected to a small light bulb with a resistance of 3.5 ohms. So R is equal to 3.5 ohms. What is the current in the bulb? So I want to find I. So all we're going to use is we're going to use Ohm's law. So the way that I remember it that I was taught in school is V is equal to IR. So even though your book has it reversed, this is the way that I remember it. This is the way I'm always going to write it down. So V is equal to IR. And again, we're given V and we're given R, and we want to find I. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So I is equal to V over R. So this is 1.5 volts over 3.5 ohms. So 1.5 divided by 3.5 is equal to 0.428. So I'm going to say I is equal to 0.43 amps, and that's it. So again, we're just learning some basic equations today, but this is the most important equation we're going to be using when we do circuits, is Ohm's law, over and over and over again. And that's it. So even though there's 6 problems in each one, the ones in practice D are all kind of just like this, and that's it.